you can review. So what we discussed for the second problem, no problem. For the second problem in part A, you want to use the payment function in Excel to find the payment. Then in part B, you want to use the payment, and I just made up a number, which is not the greatest because it's a little off, but we're going to use this number as our payment to calculate the balance remaining after the 60th payment. So the balance remaining will be valued at times 60 months because the next payment starts one period from then. There's going to be 240 of them. So we're going to use the present value function now to get the remaining balance. And then and again, this is just an example. This is not the right number. And then with that balance, you're going to repeat what you did in A to find the new payment using the new rate.
Can you share your screen?
Oh, I'm not sharing. Sorry. Yeah. I had.
So is in the payment function, the future value is the 200,000, the mortgage.
Okay, so this let me go from the top again, Barbara, and then I'll fit that in. So sorry, I thought I was projecting. So the payment function in Excel in part A to find out what the payment is. And then here you put in 0 for the future value because it's either present value or future value. In this one, you know the present value of the mortgage is $200,000, right? Sorry, I hit a button. Okay, so 200,000. Oh. $200,000 is your PV, and you use the end of payments in the function for payment, end of period payments, and you find the payment. Once you find the payment, you use it to find the balance after the 60th payment has been made. I just use a fake number here just to show that's what you do. And then once you get the balance, whatever you get there, you repeat in A, that would be your PV. So the PV from here with the PV from here, you repeat what you did in A with the new balance and the new rate. The new rate is 0.3% to find the new payment. This is a very practical problem, figure out, because people refinance all the time, and you're going to be able to take a chance to get a lower rate if you have a better credit score or whatever the case may be, and lower your payments.
So for the PMT
the first part?
Yeah, so in Excel, hold on. It's saying rate and then NPER, I guess that's the
number of periods.
Time, yeah, 60 months, number period. And then it's saying future value. So I'm supposed to
No, it's not 60. In A or in the last one? Which one?
A.
Okay. A. It's not 60. How many payments are there total?
Was it 300? Let's see, 25 years. 25 years
times 12 is 300.
Oh, hold on.
So the first time period for the first part was 300 because it's the 25 years.
Right.
Times 12.
Yeah, so that was 300.
Yes, 300.
And then whatever the mortgage is, I think it was about 200,000.
Yeah.
Yeah, and oh my goodness, what was
I missed that. Okay, so it's PV and then okay, I got it. So
and then the interest rate you have to write as a percentage.
Yeah, which was 0.004. So 0.004.
Oh, it's
comma 300, comma 200,000, comma 00. I think that's what it was.
That's right. That's
it.
Yeah.
So we use, you said I'm sorry, you said 300 or 240?
300 because
we're
it's the
talking about
first
part A,
mortgage we're
Romy.
talking about.
Oh, okay,
Yeah.
okay. All right.
And then once you get that from the 5 years, you're going to subtract that from the 200,000, and that's going to give you your new 20 years mortgage. That's how I did it. And then I started working from.
You can't just subtract it. That's what I'm showing Romy, because she did the same thing.
Oh, what do you do?
Yeah, you cannot just subtract it, because if you just subtract it, you've completely ignored time value of money, because as the mortgage is going through time, like you're paying it off, it's going down, right?
Mm-hmm.
So you can't just subtract the payments. You have to find out what the remaining balance is by also thinking about it in the time value of money. There remains whatever, so there's 240 payments remaining. Whatever the payment is you found in A, use it to find the remaining balance. So it's like a backward way to find the remaining balance of what's coming. If you were going to stick with the same payment and the same rate and all of that. So you're going to find the remaining balance. You're going to find the new PV here, or there. Yeah, well, basically the new PV.
Oh, and then so that number, you divide that one?
No, you don't divide anything. From that one, now you go back to doing the payment again. You repeat what you did in A. You're just going to repeat the same functions, but.
Oh, okay.
Okay,
Oh,
Barbara, explain.
steps.
Let's see if you got it.
Yeah, so the first one, so the second number I got was a big number.
Right.
That's not the monthly payment. That's what's left. That's what's
left. Yeah.
what's left. So now we have to see how much the monthly payment is by doing the payment function.
Again, perfect.
Right.
Oh, okay, so I have to see what my big number was, because I got the first one, but what I thought was I just subtracted from what the original 200,000. Okay.
And Romy did the same thing.
Right, so I'm gonna have to see that on paper.
Yeah.
I have to see that on paper, and I can't stop.
It's okay. It's okay. I want you to be safe. So don't worry. You can watch this after. Okay. So we did number 2, kind of. You guys are going to work on that, right?
Mm-hmm.
Romy, you're going to stick with number 2, and we're going to go back to 1 for Barbara and Patty, and TY is here now. Okay. You continue with number 2, and I will go to number TY. We're recording, so you can see our discussion about 2.
Okay.
And we're going to move to number 1. We're going backwards. So
I'm sorry, I'm interested in number 1.
Okay, we're at number 1. So you actually asked me about number 1 already before, right? So Jose is considering buying a medical lab. Oh, I changed the dates and everything. That's the other thing, you guys. I changed it I tried to make it clearer. What can I do? I'm going to show that.
While you're doing that, it said that, so basically change the first, that is the 24 to 26. That's 3 years, right? That was the question I had there. That's a 3 year.
Let me see what I put.
Yes.
It's not it. Just hold on a second.
Hello. Hi, how are you? Good. Quick question. If a patient's taking already Xarelto, and I know we went over this already, but
No, in this case, the doctor wanted Plavix, so we're giving it.
So if it's
TY, can you please pause? Can you please mute, TY?
Trying to, I'm sorry, forgive me.
Okay, I found it here. So let's read this together. So he's going to buy on January 1st, 2024 for $14 million. You have to figure out if it's a fair price. So from 2024 to 2026, the company will generate an end of year cash flow of 1 million annually. So it will be at the end of 2024, at the end of 2025, and at the end of 2026, which is 3 years. So you have 3 years on a timeline, and we'll draw it together. And then in 2027, it generates 1.5 million, and it says we're going to assume forever because it's a corporation. And we had that discussion that corporations technically, because ownership can be passed on with shares, the corporation outlives its owners, current owners. And so it could technically live forever. Okay, exist forever. So then Jose determined, according to risk of investing in the industry, 11% is the annual rate. Would you recommend? Okay, so let me draw this. I'm going to go back. So everybody's okay with my reading of it? I'm going to go back to my iPad. So we have well, let me turn that off. So it's going to be, this is 2024. And then it's 2025. And then 2026. And 2027. And then 2028. And then I'm going to use 3 dots to say it goes forever. So we're going to spend money here, 14 million. And then at the end of 2024, there's going to be $1 million. And then at the end of 2026, there's going to be $1 million. And then at the end of 2027, it becomes $1.5 million. So there's only 2. And then it's going to continue 1.5 million forever. So is this going to be worth 14 million? How do we figure it out? First, we recognize that this over here, starting one period before the first 1.5 million, is what? What is this? What kind of stream of cash flows? What do we call that when that goes forever?
Perpetuity.
The perpetuity. So this is a perpetuity. And do we know the rate? The rate stayed the same? 11? What was it? 11%, and it doesn't change. So we're going to use perpetuity at 11% for that. Do you want to figure it out together? We can just do it by calculation here.
Oh, I have an issue with that. I would have thought the perpetuity was starting from end of 2027.
It
Why are you
starts at
starting
the
from-
end there, but the formulas I taught you, the valuation is always one period before. It's always like you wait a period. Okay, so all the formulas I taught you, you have to wait unless I talk about beginning. But for the perpetuity formula, I said you have to get the value at 0 and the first payment at 1. So this is like the valuation is at 2026 and the next one, the first payment is at 2027. It's just one period away. That's the formula I taught you. Okay, so then you're going to put the first cash flow here. So it's like, this is the formula that I taught you. So if we plug in 1.5 million, and we'll just do it with all the zeros, and then 0.11, what do you get?
13 something. I could try to get it for you. I have 1363 13636363.64.
Are there commas in there? How many? Okay, let me do it.
Well, okay, that's 13. Okay, I'm gonna 13 million. 13
Okay,
million.
you're right, 13 million.
13,636.
It's very repetitive. 36364.
Yeah, but I
You
was
know, I can't give you the rest of the answers. I just gave you an answer, but okay, so that's what you do for that. And then the other two, what do you do? So basically what you have here, you can do an NPV, right? Because you have the first one, the second one, but also you have to add this to it.
okay.
Because there's this other amount here that you calculated. So in the NPV, you can put this one as the first one and this one with this one together as the second one, and that's all you have to do. Are you following, guys? Ladies?
So we're for this one, there's two separate MPVs for 24, 25, and then a separate MPV
No, there's just one MPV. What we did was we had to do this manually. There's no fancy function in Excel for perpetuity. You just have to do the calculation, the mathematical calculation. So if you have a perpetuity, it's very simple function. You just have to recognize that that's what you have. So once you've got it, this is the number. It's $13 million, and you're going to add it to 1. And then you're going to make an NPV with those two numbers. That's it. So the trick was, how do you combine perpetuity and just like regular annuity? Just do it with an NPV, but you have to summarize what this number is. You have to do a calculation first.
Okay, I still have a problem with that.
Yeah.
Because, so like, for me, for all the other sums, I was able to do them in 2 different ways. That way I could counter check that I did it right. But this number 1, obviously I was even wrong because of the 1 period was not supposed to be part of it. So I still have a problem with that. Maybe I don't know if I could wait after, or if you want to talk more.
Well, you have to go back to the notes and see. That's what we did. Let me convince you. Was it this group? So everything was always 1 period away. All the formulas were 1 period. They started 1 period away. You see? It's always 1 period. I don't think these are your notes, even though I think we used a different set. Hold on. Those are the calculator notes. Those are the calculator notes. Hold on, let me get that. So I didn't teach you the calculator. I just taught you Excel. I'll make it easier. So here, time value of money.
Excuse me.
Bless you.
This is before we did the annuities. That was before the annuities. I gotta find the file. I'm gonna put it in here. 3. The Cooney file. 240. PV. Why I don't see it. I'm gonna have to load it. Hold on. Okay, so
Can I ask one more question though? One question?
let's finish this. Okay, so
Yes.
in these notes here, all the formulas that I use, the first cash flow is always one period. You see? It's always one period away. One period away. Are you watching? One period
Yes.
away. It's always one period. All of them. Okay. And I said to you, if you need to do anything different than this timeline, you can't use these formulas. You have to adjust your perspective to the formulas because you can't use them otherwise. Everything you see, everyone is one period away. One period away. Oh no, this one is not. And this one I told you, this is beginning when it's just right here. And when it's beginning, you have to put the 1 inside the formula at the end, not 0, to tell it that the payments are at the beginning of the period. But otherwise, it's the formulas are all for the end. And see, I have a new formula. I created a new formula because I can't use the original formula. It doesn't apply. I created something new here because the original formula only applies starting here at number 1, and it only applies for 59 payments. So that leaves this one out. So I have to create a new formula with the original annuity formula plus that first one. So if you do not have things, payments starting 1 period from valuation, you have to adjust your formula that you used. You have to, there's a modification you have to make. So I don't expect you guys to write out the formulas, but you need to know to put a 1 there in Excel because things changed. All right, so ask me your other question, TY.
I don't think it made sense.
Hey?
I still have it.
But it's true though, right? Every formula is always, payments begin 1 period away. Yeah, that's how it works. That's how the formulas work. All right, let's go back to, so what am I doing next? So I'm going.
So
So
I'm
we were
sorry.
here, so you need to put these together in the NPV. So use the NPV. Where this is your first one. And this is your second one. Those sum together.
Okay. Okay.
Now you don't have.
So that means in calculating this NPV, we only have 1 period that we're putting in the calculation apart from the perpetuity side.
Well, when we did NPV, let me go back to the notes again. So when we did NPV in the notes, oh, so
In the
NPV,
first part of this question, do we have to find the rate?
no, the rate is 11. It's given. So for
Because I think what happened was I tried to find the rate for the first 3 years.
yeah, you don't need the rate. You get the rate.
So the 11% is for no matter what, it's the first.
11% will be considered their required rate of return for the analysis. It's
regardless of if it's 2024, 27, 28,
yeah,
29, 30.
Yeah, exactly.
So unfortunately, I was trying to see how I can figure out how to find the rate for the first 3 years.
Okay. Yeah, no, you don't have to.
Because I didn't know that 11% was attached. Because in the end, the conclusion is it is worth the purchase.
I didn't do the calculation yet, but you're gonna check if this is worth $14 million or more, right?
But so we're looking for, is it worth 14 million or more, or is the return going to be worth it? What is that?
Yeah, both. That's well, Okay, the NPV, what it does is it compares your future cash flows against the potential of just going to financial markets and doing something else. That's why you plop 11% in the formula, because you believe you can get 11% in financial markets. So you make the calculation against that, and that's what the function gets you to do.
So what was the point in separating the years from 2024 to 2026?
So you're gonna make the purchase into 2024, but at the end of 2024, you earn $1 million. At the end of 2026, you earn another $1 million, and then you're starting to earn $1.5 million forever.
Okay, got it.
So you should
At
draw the timelines,
but-
and that will help me know like how you interpreted it.
But then that doesn't equivalent to the 11% though, does it?
Well,
It
you have
doesn't,
to
like
find out, you want to find out what this is worth. So to figure that out, you're going to use the NPV function, noting that in Excel, NPV means something different than what NPV is. Like the NPV function in Excel is really giving you the present value of future cash flows. So, and that's all we really want. Right? And if we want to do the NPV function here, we would put negative 14 million to see if it's a positive or negative. That's what we do. So we do what we did here. This one was 3 million, but we're going to put negative 14 million there. And then plus the NPV with the two cash flows that you have. You have 1 million. And then you have in 2026, you're going to have, 1 and then the 13. You add it all up and you say 14,636,363 and 64 cents. That's what's going to go as your second, and then that's it. And you're going to see if it's a negative or positive.
Wait, so the cash flow isn't, the 13 million is considered a cash flow?
The 13 million is the present value of all the future cash flow. So it's a lump sum representation of the future 1.5 million forever. So that you're going to treat it like you're just going to add these together, and that will be the one cash flow.
So it'll be plus
You
the
plus
13
these together as your second. So you're going to have, this is your first cash
I
flow.
can see what you're writing. You're writing
And this
something?
is, oh, I got to put it, thanks.
Oh, okay.
I got to put it because I was sharing the document on my.
So the only cash flow before the perpetuity is the 2025 one. That seems to be what I'm getting from what you're saying.
I've drawn it here. It's 2025 is 1 million, 2026 is 1 million. And then the 1.5 million forever is summarized in $13 million that we calculated here.
Gigi, no.
13.6 million represents all the 1.5 millions forever. So this is now summarized. I don't have to think about this anymore. I've already computed what it's worth. But it happens at 2027. So I do the valuation one period before, and I can just add these numbers together.
But I'm still a little confused because you're saying that you're getting rid of the 1.5 million, but then you're keeping the 13 million. I'm confused.
No,
I'm not getting rid of it. I'm just saying these numbers are already been used, and I summarize them as 13.
Okay. Just one more question. And at the end of 2020, 2025, you said we are not counting 2024 because it's one period forward. So 2025, 1 million. 2026, the 1 million there is not counting because it's going to be part of the perpetuity. That's why
it's not going to be part of the perpetuity. The perpetuity, I appreciate your questions, TY. The perpetuity only uses the 1.5 millions. And now I put them all together from 2027 to the future, and they all wrap up over here with this very basic formula to say that they are worth $13 million at time 2026.
So we have 2 1 millions to consider.
Yes, but 1 million happens over here and 1 million happens over here, and you can't just add them because of time value money. You have to put them together. So what will the second amount be worth? It's going to be 14 million.
14 million. Okay.
363.64. That will be the
the 13
and that will be the first. Okay.
Okay.
And then make sure you put them correctly into the NPV formula against the 14 million investment and see if it's worth it. It looks like it probably is, but you got to check because it's a pretty high interest rate of 11%. That's going to erode the cash flows in the future, right? So try that.
Wait,
And you know what? I'm just giving, I'm not giving the answers. I'm giving you parts of the answers, but I want you guys to just work on it and tomorrow you can tell me all about it, okay?
So this
So-
14 million is not the answer. We're not done
No,
yet.
no. Now you have to do this.
The NPV, but
Yeah, and that's the first cash flow. That's the second cash flow. That's the rate. And your original investment was how much?
14 million.
Right.
so it's 14 million plus the other 14 million. Oh, it's a negative. Oh my lord.
That's the investment, Barbara. We're gonna spend like
Oh.
look back here. Remember what we did here? Just keep going back to the notes. I have the exact. I just gave you simple examples and questions that were similar, so you could follow along.
Thank you.
So
Thank you.
always go back to the notes because that's your anchor. So remember this
I
one.
think it's the questions that's throwing us off.
Yeah, they're very wordy. They're very wordy, right? But you can
Yeah.
ask me to clarify. Okay, so anchor your concerns with try and find a similar problem in the notes and then ask me, okay, what's missing or what's not. So we have the 14 million, just like we had the $3 million expenditure on the hospital. Remember the hospital?
Yeah.
And then we put the NPV in there with the rate and then all the cash flows, but we only have two. We don't have all these zeros and things. We're just going to put the first one and the second one, and that's it.
The first one and second one, that's the one that's 14 million.
Exactly.
So the number, okay.
And we don't know if,
So it's about $600 difference, $6,000 difference.
did you do it already?
No, I was just guesstimating if one is if it's negative 14,000,
Yeah,
negative 14
Yeah,
million.
so, yeah. The thing is that these, okay, so this one's negative 14 million. It looks like you're going to be fine, right? It looks like it's worth it. It does kind of look like it, but you need to find the NPV by, because you have to take account that 11%, there's 11% discount rate that lowers the value of the $1 million in the future. Remember that, the whole time value of money thing. That's why we're doing these formulas, because we're trying to keep track, we're trying to keep account of the fact that money in the future is not worth the same. We can't just add the million and the 14 million.
Where are we putting the
percent.
11% though in this formula?
And it's
And
the first one, the rate. It's called the rate. It's in the NPV formula.
Oh, okay. I thought that was
You
just
see, it was 8 over here on this problem, Barbara. And
yeah.
now it's 11.
Oh, so it's gonna be 11, and then
I think what happened is when you brought in the 11% at the end, it was just to compare our answers into what we found. Like, it didn't seem like the 11% was part of the whole entire problem.
Yeah, it is. It is. It's the 11% is what Jose is going to compare the investment against, because if he doesn't invest in this opportunity, he's going to go to the financial markets and earn 11%. So that's why you're using the 11%. It's his required rate of return. It's what he wants from this project. So you're going to check if it's worth it. You're going to check if it's worth to pursue. And it looks like it is, but you just got to check to get the NPV to make sure. Because at $14 million in 2 years is not $14 million today. It's less. But it's probably offset with the 1 million in 1 year, and it's probably going to be just fine. Like Barbara was saying, 636,000 is still there, and you got the 1 million, and it's probably enough. So put it all together in the formula, just this one, like this one here, the 11%, the 2 cash flows, close the bracket, add it to negative 14 million, and see what you get. And it should probably be a positive, I guess. So I gave you guys way more information than I want to in one. So 2 we did. The recording I'll put up on the site. Okay, so what else are we going to do? Let's look at 3.
Sorry, okay, we did 2 like that, right? We are all
We did 2. We did 1. We did 2. And then we're gonna look at 3. Romy started asking questions.
Can I see what you did with 2? Because I'm sorry.
But you can watch the video, okay?
Recorded, yeah.
Okay.
So 3. So 3, I'm just looking at what Romy did. She did a nice presentation for me here. So this one was supposed, okay, let me, I'm gonna just show, if you don't mind, Romy, I'm just gonna show
That's okay.
I won't show your answers, I'll just show your drawing for 3 and the question you typed out. I don't expect you guys to do what Romy did. She just did a lovely job and I appreciate it. Okay, suppose that a for-profit hospital pays a quarterly dividend to its shareholders. It has just paid, you guys can see this? It has just paid a dividend of $5, okay? Investors will use a required rate of return of 4% quarterly to value their stock in the hospital. What is the current stock price? So what do you do with that? So now go back to the notes and look for the similar problem. So which one would it be?
Is it the oh my God, the thing over?
The same with
I don't know
perpetuated.
yeah, it was 125. How did I do it?
Okay, so let's go look at the notes.
The stock price
Yeah.
over the dividend.
So let me go to the notes and see the perpetuity. Is it here or in the other set of notes? I don't remember. So okay, here. Yes.
Okay.
So there's the formula, right?
Mhm.
Now you got to just use the first one that starts 1 period from now. It's still $5 and it's $5 forever. So you just divide by, what does it say? 4%.
0.04.
Right. Now the fact that the first cash flow, I don't have one here. You see, it starts at 1.
Okay.
But I said that there's $5 dividend today, but that does not get included because if you're valuing stock, if you purchase the stock, you have to wait like 3 weeks to get any dividends. So if you're trying to get the value of stock here at time 0, you have to wait 1 period to get the next one. So that $5 is not included in the first $5. So what I'm trying to say is it matches the graph. It matches the chart or the if you just use these ones, it matches exactly the formula. You don't have to worry about the first $5. You can just cross it out, Romy, because it's just telling you they paid $5 to tell you what it pays. It doesn't change, but you don't get this one. You just get the one starting. So your quarters are, I would say, I would put a 0 here, Romy.
Yeah, I put a 0. I changed that one to 0.
Okay, good. And then this one 1 and that one 2. That's good. Just try and copy what I've done as much as possible. And there you go. And then this one you don't get, so I'll cross it out. But you put it there because they gave you the information, but you're not going to get that one. And now it matches perfectly my notes. And there's no growth. There's no growth here. It's just a simple problem. Simple perpetuity. Okay, let's look at number 4. Okay, I have my assignment here, number 4. Oh, there's only one more. Okay, that's good. Okay, so one more. Sonia has been offered an investment opportunity that produces cash flows of $14,000 that she receives at the beginning of every year for the next 5 years. If the required rate of return is 10% effective annually, determine the fair price that Sonia would be willing to pay for this project. So what do you do here? Which formula should you use?
So the NPV formula?
You could use the NPV formula, yes. The only thing is that the first cash flow, it's a little bit different here because The first cash flow is not an investment. And you want to find out what it's worth. This is better done with an annuity, frankly. This is better done with an annuity to find the present value of an annuity, but with the beginning payments, beginning of the year payments. So that's going to be the PV function with a 1 at the end for the beginning of the year payments. Do you understand?
Instead of 0, it's going to be 1 because now it's at
Beginning here.
beginning. If it was at the end, it would be 0.
Right. Okay, so I'm gonna say, TY, review the video for the second one. The second one, what we did there was you had to find the payment. So use the payment function. And then for part B, you need to find out the remaining balance after 60 payments have been used or made. And I show you how to do that. And then with the remaining balance, so there's 2 parts to part B. You have to find the remaining balance, and then you have to repeat what you did in A. You have to repeat what you did in A to find the new payment with the new interest rate because you're refinancing. So part B has like 2 parts to it. And I'm going to let you guys work on that because I gave you a lot of material there. I'm going to let you work on that. I'll upload this video, and then tomorrow at the beginning of class, we can talk about it some more, and you don't have to hand it in until midnight. Okay. If you need to work on it still. I know you're going to be tired, but it's the best I can do to get this done. How's that sound?
Thank you. Yeah, sounds good to me.
Thank you.
Okay, so I'm going to upload this, and then we'll talk at the beginning of class, and you'll still have time to discuss it with me. Okay.
Okay,
right.
thank you so very much for this.
Tomorrow.
Okay.
Good night, guys.
Good
Good night, guys.
Bye.
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 Bye.